Good morning to all. So today we are going to see that how can we hear the various sounds. So you know that the organ which will be used for sensing that various sound, that is called ear. So today we are going to see that the structure of human ear. First one, the human structure, that human ear will be split as three different category, right? So that means the ear will be split as outer ear, middle ear and inner ear. Okay. See, just you just read that parts. Okay, first you had pinna, hammer, anvil, stirrup, vowel, window, auditory nerve, and cochlea, and tympanic membrane or eardrum, auditory canal. So these are the different parts inside of human ear. So first one, we have to know that the outer ear. So how can we hear that various sounds? As you know that air, so air is compressed of lot of molecules, right? So lot of molecules, that molecules, whenever the sound is produced, there will be some vibration. Is due to that vibration only the sound is formed, am I right? So due to that vibration, these vibrations and all carried here, carried in the medium of air, right? So this pressure, that vibration, we call it as here pressured variation or pressurized waves. Okay, this pressurized waves, first it has to be enter in that outer ear. Okay, then after it will go, that the pressurized waves, it will go through the air canal. So this structure is called air canal. Okay, so through this air canal, the pressurized waves and all carried to that. Okay, so this is kind of a narrow tube like structures. Okay, so this is called air canal. So at the end of the air canal, so there will be a vibrating, like what's called thin membrane is there, that is called eardrum or tympanic membrane. Okay, so here they said the eardrum, so this is called that eardrum or tympanic membrane. It's kind of like a thin balloon sheet. Okay, so when this pressurized waves, when this pressurized waves enter into this what's called eardrum, so as you know that the eardrum will be vibrate. So vibration means what? So vibration means, see, actually vibration is nothing but a series of compression and rarefaction, as I said in my previous class. So compression and rarefaction. Okay, so this whenever what is called this eardrum will be compressed, so that time this pressurized waves, it will be going inside. Okay, so it will be going inside, so it will be compressed. That time the pressure will be increased, right? So when the rarefaction will be happen, the pressure will be relaxed, the pressure will be decreasing. Okay, so when the compression starts, when that means when the eardrum is compressed, so that time this pressurized waves will be carry forward still ahead. So still ahead means there are three structure is there. Okay, three small part is there, that is called hammer, anvil and stirrup. Okay, so here I will write hammer and this is called anvil and stirrup. Okay, so this pressurized variation, first it has to carry in the hammer. Okay, see this hammer will be passed this vibration into the further part anvil, and the anvil is contact with that stirrup, so that from hammer to stirrup this vibration will be carried. Okay, and then what is that means? See here, see, this is called the middle air. Okay, so and inside what will happen? So inside here, that cochlea, so this is called cochlea. Okay, so inside that cochlea, so there are some what's called the liquid is present. So this pressurized wave, that means this vibration will be carried from the stirrup to that cochlea. So the cochlea, so it absorbed that vibrations and it will convert that vibration, that means pressurized waves, into electrical signals. Okay, so electric electric impulse like. Okay, so that electric signals and all, this sudden impact of the electric signals, further it will be carried to that what is called auditory nerve. So from this auditory nerve, it has to be reached in the brain. Okay, so first you have to know that the air is consist of lot of molecules, lot of what's called lot of air molecules and atoms and all present. So whenever there will be any external disturbances there, first it has to be carried in that pinna, and the pinna is nothing but it is called outer ear. Then the pressurized wave will be further forward to the tube that is called air canal. Okay, so through this canal, what is called all the molecules and all compressed. Okay, so whenever the compression will be happen, pressure also will be increasing, so that compression will be carried further to the hammer, anvil and stirrup. So these are the organ, it has to be just amplify that one, it just amplify that vibratory waves. Okay, and that waves will be carried further to that cochlea, so that cochlea will be convert that sound waves into electrical signals. Okay, and this electric signals will be further forward to that what is called auditory nerve, and from that auditory nerve, so it has to be reached in the brain. So this will happen in the fraction of time. Okay, so this is that human ear structure, students. So just understand about it. So just see the picture and understand that the different parts and how it will be carried to that human brain. Okay, and the sonar pulse which returns from an underwater cliff in 1.02 second. If the speed of the sound in salt water is 1531 meter per second, how far away is the cliff? Okay, so first one we have to know here. Okay, so just wait a minute. So okay, first you have to know that here a submarine emits a sonar pulse. So first you have to know that some sonar pulse. Okay, so this sonar pulse will be carried, so this is the seabed. Okay, so this sonar pulse will be from the submarine, it emits a sonar pulse which returns from an underwater cliff. So it will be returned, so after it will return, so it will take 1.02 second. Okay, and if the speed of the sound in salt water, that means that wave speed. Okay, that a submarine emits ultrasonic waves, that speed. So that speed they given that is called 1531 meter per second. So how far away is the cliff? So first one, just understand the problem first. So submarine, as you know that what is mean by submarine? Submarine emits a sonar pulse. So first, from the first line, submarine emits a sonar pulse, and which returns from an underwater cliff. Means after some disturbance, it will come back to original position. So it will take some time. That time they given 1.02 second. If the speed of the sound in salt water, that means speed of the sound they given in the water is the medium, right? So in that water, the speed of that sound in salt water is 1531 meter per second. So how far away is the cliff? Okay, that means how far. So how far means they asked the distance. Okay, so they asked the distance. So first I will write that first given value you have to write. Okay, so what is that given values? First you have to write that given values. Okay, see here first I will write. So given what are the values they given? First one, what is the called the time they given? So time equal to 1.02 second. Next one, the speed of that sound they given, that is called 1531 meter by second. And how far? So how far means they asked the distance. Okay, so they asked the distance. Okay, so distance they asked. Okay, see first one you have to know that what is the formula which relate with that speed and distance. Okay, so first one solution I'll write here. So speed equal to distance divided by time. Okay, speed equal to distance divided by time. Okay, so distance first, what is the total distance actually here, students? First see here, it will be going here and it will reach the seabed and it will come back here. That means this is D, means this also D. So what is the total distance? So D plus D, which is called 2D. Okay, so that means 2D. Okay, 2D and divided by time. So time taken here 1.02 second. Okay, so speed they given 1531 meter per second. Okay, so speed they given and distance we have to find and the time they mentioned. So first we have to calculate the value of 2d. So 2d, what is the value? 1531 into 1.02. Okay, so just multiply this value. So 1531 into 02. Okay, so 1 2 sir, here I will do here 1531 into 1.02. So 1 2s are 2, 3 2s are 6, 5 2s are 10 here. So 1 2 3 and again 0 0 and 0 0 and 1531, right? So here 1531. So 261,651. So and after two decimal points, so here two decimal point, no, so that means 1 2, so 2 after you have to make a point, so that is called 1561.62. okay, so 2d, which means that 1562 meter. Okay, so here this is called 2d, which is nothing but the total distance. Okay, so 2d represent total distance. Okay, so total distance. So total distance 2d, which is equal to 1531.62 meter. But we have to know that how far away is the cliff. That means from the cliff how far. So that means d only they asked. So d only they asked means d equal to 1531.62 divided by 2. Okay, 1531.62 divided by 2. So that means just divide it. 1 2s are 2, 7 2s are 14, and the remaining 1, so 6 2s are here 12, and the remaining 1, and here 1 5 2s are 10, here 1 here what's called 116. Okay, so 8 2s are 60, 8 2s are 16, and 1 2s are 2. Okay, so 765.81. so again you have to check. 7 2s are 14, and the remaining 1, so 6 2s are 12, and the remaining 1, and so 5 2s are 10, so remaining 1, so 8 2s are 6 16, 8 2s are 16, and here the remaining 2, 1 2s are 2. Okay, okay, so next to one, what is the thing is, so 765 point, the distance will be 765.81 meter. Okay, so this is the answer, students. So just to note it. So I will explain about this again. A submarine which emits a sonar pulse from that cliff. Okay, so to that water, so underwater cliff. Okay, underwater cliff, it will reach certain distance. That distance we have to calculate. Okay, so here the answer is 765.181 meter. Okay, so just check the answer, students. Okay, see. Okay, so wait a minute, student. Just we have to check the answer, whether the answer is right or not. Okay, okay, sorry students, just a minute. See, 1561.62, but here I put 1531. Okay, so just we have to just here 1000. Okay, first here multiplication 1561.62, no, so 1561.62, and you have to divide by 2. So divide by 2 means 1 2s are 2, 7 2s are 14, and the remaining 1 8 2s are 16, and here what is called z, it will not divide, no, so 780 will come. Okay, so 780, and then after 1 it will combine 16, 8 2s are 16, and 1 2s are 2, so 780.81. okay, so when we multiply this value 1561.62, you have to divide that value, so 780.81 meter, so that is the answer. Okay, so next problem, we have to go to that next problem. A person has a hearing a range of 20 Hz to 20 kilo